Welcome back. Now, as I mentioned in the previous video, this problem is part of the manipulative kind where you have to move things around, modify things around to solve the problem. Okay. Now, this is very easy. Maybe at the first instant when you see it, it looks all complicated. But what I'm asking you to determine is the physical value of equilibrium constant K3. Okay. And this is the net reaction, okay? Whatever the K3 is, whatever reaction associated with it is the net reaction, okay? Now you have to modify everything in the two reactions above, which when combined, gives the net reaction. You have to modify them, manipulate them, move things around, maybe add, maybe divide, whatever you have to do to get the equation into this form so you can solve for the value, all right? Now, without further ado, let's actually write the expression for K3, okay, which is SO3 squared product over reactants. Now, whatever the number in front becomes the exponent, so that's not hard, okay. All right, now do this first. Oh, sorry, it should be 1. It should be 1. Okay. Now, let's be a little surgical about it the first time. Once you understand it, and if you find a way of your own that works for you, go with that. This problem can at least be done in more than one different method. I'm only showing you one of the methods that I found helpful. If you find something else, stick with that. All right. What you need to do is you got to figure out things and put them in place so every term is only on the side where it's supposed to be, okay? Now you see the net reaction, the SO3 component, where does it appear on these two? Well, on this, it doesn't even appear on this one. It appears on this one on the right side, which is where it should be. So do not disturb this equation. Leave it be for now, okay? Now let's go to this side. The SO2 is one of the components that you can focus your attention on, because if you notice the S8 is not even in the net, so it must be gone. So we must find a way to get rid of it. And the SO2 is on the left side here on the net, whereas in the individual reaction, it is on the right side. And that means one of the equations has to be flipped. I would never flip the net. I would flip the individual equation. So what do? Well, basically, you rewrite the equation in the opposite direction. So 2SO2, 1/4 S8. People that love a lot of math usually would love these kind of things, okay? When you do this, it's no longer K1, it's 1 over K1, because it's inverse of, if you do math, if you write the K expression of this and then take 1 over that, you will get the opposite. So that's essentially why we write 1 over K1. That means it's 1 over 1.8 e to the 10. So this is the new equation we're going to work with. Leave this be for now, okay? Let's rewrite that here, actually. So 2SO2 going to 1/4 S8. Leave the value for now untouched. Now what we need to do is we need to convert this equation into a form. Okay, when terms are on the same side, you can add them. When terms are on the opposite side, you subtract them, or however you want to do it, okay? Let me show you one method. So ultimately, what we want is, well, we got the 2SO2. It looks like this. So now let's focus on this one, okay? This got 1/8 S8, and this got 1/4, right? Let's rewrite this one exactly the way it appears. And I do that because, like I said, you need to be a little bit surgical about it, because, you know, that's the way I had learned it. Once you learn it, you can find your own way. Now, what we need is, we got our SO3 in place, we got our SO2 in place. What we also have in place is O2. But what we only need is, we don't want the S8 at all in our net, and our O2 should just be 1. You see? So, but the SO2 here is there, so let's not even do anything with this equation. If we can find a way to convert the O to if you can somehow convert this to 1/4, then problem solved. I think it would automatically fix everything else. So how do we do? If we multiply the whole thing by 2, what does that do? Well, that becomes this 1/4 S8 plus 3O2 going to SO3, 2SO3, right? Now this equation, let's strike it off on the picture. So now you see when terms are on the opposite side that are alike, you can cancel them out. So 1/4 S8 cancels out. Terms on the opposite side, you have to subtract them. So let's rewrite everything. So that means there's nothing to cancel or add to SO2, so it stays the same. 3O2 plus O2 means there's one O2 left on this side, and then there's nothing to add or subtract to the SO3, so that'll be 2SO3. Right? So we got our net equation back. That means this is the equation that we are going to have to do. So what we have to do now is we have to multiply K2 by 2, right? Because that's what we had to do to get this expression, right? So that means K2 has to be multiplied by 2. And this is 1 over K1. So if we multiply these two, right, then we will get this expression back. If you, that's something for you to do, okay? I am not going to do it. So, I mean, what I'm saying here is if you do O2 over O2 over 2 times S8 over 1 over 4, that's 1 over K1, right? Basically, right? Divided by SO2 squared. This is this. If you multiply this times 2 times, you know, this SO3 over S8 1/4, you know, 1/8 times O2 3/2. Okay, this will give you your K3. This is how the problem would work, but it's much simpler. So all we're going to do is 1 over K1, which is 1 over 1.8 e to the 10 times 2 times whatever the K2 value is, 1.7 e to the 7. Basically, you must find a way to convert everything. Well, normally when you're adding to get this, right? So which means it has to be multiplied. You're adding this and this, right, to get this, right? So that means whenever you add two equations, the expressions ultimately must be multiplied. So if you do the math here, this is a long problem. Sorry, it is one of those problems that requires detail, and I had paid attention to detail here. So times 2 times 1.7 e to the 7. So the K3 value is 1.9 times e to the negative 3. There you go. That's a long problem, okay? This is how the expressions are multiplied. To find the numerical value, you have to remember that we flipped the equation, so this is 1 over this value. We multiplied 2 over this entire equation to get it as 1 over 4, so we can cancel it out. So that means this needs to be multiplied by 2. This is 1 over K1, and that's what when you, and then we added these two to get the net gain, which looks like this. So when you add equation in algebra, you multiply them eventually, and that's exactly what I did, and that's my K3. This is the mathematical expression on how you multiply. If this problem seems overwhelming to you, just practice it, okay? There's, again, we're going to do a quiz on it, homework on it, and multiple in-class activities. So this is the type of problem you want to take on because it's challenging. It makes you think. It's not one of those problems where you plug in, and you get the right answer. Well, those things are good. Those are easy. Yes, you do need them every now and then. But sometimes you need to challenge yourself, and this is one of those problems where it challenges yourself. How much you know, how good you are, things like that. So, all right, so if you can bypass this one and understand it, this will be on the exam in one way or the other, so you better know it. And then the remaining three problems videos are very, very easy, so stay tuned.